Hey students, in today's video we are going to learn about the EOT for the term 3. Okay, and today I'm going to start with question number 1 of the writing part, because I know students are struggling more in the writing part as compared to MCQ. Okay, so let's start with the question number 1. So question number 1, solve the problems related to self inductance. Okay, this is the first thing, of a solenoid. Okay, as mentioned in the textbook, this is the page number 241. We need to understand two things here. First, we need to understand what is solenoid, then what is self inductance and how this property is used, and then we will solve the numericals. Okay guys, let's start. So the first topic is what we have, that is the solenoid. Okay, I'll make it a little bit big. So the first topic is solenoid. So as per solenoid, what is solenoid? We need to understand. Let's say this is a piece of iron, okay, and there are lots of wires are just moving like this. There are lots of wires. So there are three things you need to understand. Capital N, total number of rounds, total number of circles. Yes, okay. L, let's say this is your length, L. So L is the total length. And what is small n? Small n is equals to capital N by L. What is called number of windings or number of circles? Number of windings per unit length. Per unit length. This is the thing. Okay, what is the use of solenoid? It is also called electromagnet also. So what happened here, whenever there is a flow of current, okay, I'll just write it again for you. Flow of current. So what will happen? It produces magnetic field. Magnetic field, and which gives you as a, it behaves like a magnet. Behaves like a magnet. Okay, so there is a magnetic field also. If it behaves like a magnet, so it will gives us a magnetic field. So in that case, what is the magnetic field of a solenoid? Mu naught n I. Try to understand. Mu naught is a constant whose value is 4 pi times 10 raised to the power negative 7. Okay, this is a constant value. No need to worry about too much. N, I told you, capital N by L. Depends upon number of turns. Depends upon number of turns. If more turns, more, you can say B is directly proportional to small n. If you have a more number of turns, more magnetic field. Less number of turns, less magnetic field. Clear? And third factor, that is the most important factor, that is the I, which is equals to current. It depends upon the value of the current. See, B is directly proportional to current. More current, more magnetic field. Till here clear? Sure. Okay, so second thing what we need to understand here, so that we can continue with this topic, the second term is called the flux. Second term is your flux. What is flux? If you remember, flux is BA cosine theta. BA cosine theta. What is the meaning of flux? Number of line of forces. Number of line of forces passing through a unit area. Passing through a unit area. Let's say if the angle theta is equals to, what is should be the angle? It should be 0 degree. Then flux is equals to BA cos of 0, which is equals to BA. Clear? Fine. Okay, what we need to understand here, the next and the third is the major word, that is your self induction. Self-induction. What is self-induction? That is phi is equals to L times I. Phi is equals to L times I. Here we learn BA. Here we learn Li, where L is your self-inductance. We will learn about the properties also. What is the self-inductance? So here, first we need to understand the formula. So can I say flux is equals to BA, which is equals to Li. This is for one turn. Remember, for the one turn. Because if we are learning about the solenoid, in that case, we have number of turns. So if we have the number of turns, just remember, if we have number of turns, then how can we solve this? How can we solve all these things? So can I say n times of flux is equals to Li. N times of flux will give you the self-inductance and in terms of current. So can I say n times of BA, which is equals to L times of I. Okay, solve this. So we know small n is your capital N divided by L. So can I say capital N is equals to small n times of L. So small n times of L times of BA, which is equals to Li. Just remember this thing, because one more step and you will understand the formula. So what is the magnetic field? We learn about the solenoid. So in case of solenoid, we know B is equals to mu naught n times of I. Place the value NL bracket mu times of N I multiply area, which is equals to Li. So what is the value of L, guys? Just okay. I and I cancel. So what is the value of L? Can I say L is equals to N multiply N? So N square, okay, L mu naught A. So how we write this? L is equals to, okay, I'll make it much better. L is equals to, not small l, it should be capital L. Capital L is equals to mu naught N square L times A, and where area is equals to your pi r square. Pi r square, and you need to focus on this value. What is your L? What is your self-inductance? Okay, this is your major formula you are going to use in the numericals. There is one more thing what we need to understand. There is the word called self-inductance. It is a property what we need to understand. I will add a page here so that you can continue. So the word is called self-inductance. Self-inductance. What is self-induction? I will explain its definition, but the first thing what we need to understand, as we know, as per the Lenz's law, V induced is equals to negative d phi over dt. Yes or no? We know this thing. Okay. Here also, what is self-inductance? V induced. Just place the value negative. What is phi now in case of solenoid? As we know, n times of flux, which is equals to Li. Yes or no? Okay, so can I say n times of d phi over dt? So can I say negative n times of d by dt of Li? Yes or no? Yes or no? Okay, so bring negative n L times of di by dt. So in case of n is equals to 1, then V induced is equals to negative L di over dt. Now we need to understand what is self-inductance. What we are understanding from all this equation. Can you solve like this? V induced is directly proportional to negative current? Yes or no? Okay, what is the meaning of this thing? What you need to understand? Let's say I said current I is 10. Then what should be the value of V? Can I say it should be negative 10? Yes or no? Sure, because it should be negative. Okay, if I say current is declining, I becomes 5. So what should be the value? V is equals to negative 5. So from negative 10 to negative 5, can I say it is increasing? Do you understand this point? Okay, I will add one more page for you so that you can understand this thing. Guys, this is very, very important to understand. V and I, and you need to focus on this value. Okay, 10, 10. Can I say both are equal? Okay, I said 7, 10. Who is greater? Can I say 10 is greater? Okay. Now just change the sign. Negative 7, negative 10. Who is greater? Can I say negative 7 is greater? Yes or no? So now you understand this point. 10 to 5. If you are moving from 10 to 5 in terms of current, that it means this is decreasing. But if you are moving from negative 10 to negative 5, it means you are increasing. Is it fine? Okay, now we need to understand what is self-inductance. See, self-inductance is a property. Self-inductance is a property of a coil due to which it oppose any change in the value of current. It oppose any change in the value of current. Let's say what will happen here. We will understand. Let's say I'll take this diagram and then I will explain this. Okay, first I will remove this. Okay, take this diagram and try to understand this concept. Copy and paste. Okay, on which factor we need to focus here? I told you whenever the current tries to change and it will oppose. Let's say this is our coil. Okay, this is the coil. Current is increasing. We have the formula V induced is equals to negative L di over dt. Yes or no? What is happening here? Current is trying to increase. Then what will happen with the V induced? It is decreased. Do you understand? So current is moving this side, trying to increase. Then voltage is opposing him. Fine. Okay, now the second case, what you need to understand. Current is decreasing. V induced is equals to negative L di over dt. Current is reducing. Then what will happen? Voltage is increasing. Means in the same direction. Same direction means if you observe with the values, let's say I'll added a page for you. Okay, now try to understand, and this one, both cases with the numbers. Okay, now what I said, current is increasing. Vi, let's say this is your I1, this is your I2. I is 10 now and voltage is your negative 5. Clear? If the current is increasing, it will become 20. Then what will happen with the voltage 1, voltage 2? Just think and tell me what will happen with the voltage. See, current is increasing, so voltage will reduce means negative 5 or let's say better for you, negative 10. Now it will become negative 20. Do you understand? So you will understand it is decreasing. Now the same thing, V1 V2 I1 I2. I'll give you same example, just try to understand. Let's say now what happened. Let's say I2 is your 20. Now I1 is your 20. I2 is your 10. What is happening? Decrease, yes or no? That can I say the new current is decreasing? So voltage negative 20, negative 10. What will you say? Think and tell me, huh? The value is increasing. The voltage value is increasing. Yes or no? Fine. That's why we will say they are moving in the same direction. Clear with the numbers? I thought it's clear. So this is as per the Lenz's law. Whenever current increase, voltage decline. Do you understand here? Increase, decrease, and here decrease, increase. Clear? But the directions, you just need to focus on the direction. See, direction, direction. It is trying to support him. Fine. So this is your self inductance. So what is your learning here? Just you need to focus on this point. From which page we get all these things? Okay. Now remove this, and what are the learnings? You need to focus on that point. Okay, remove this. Okay, what are the two key learnings? Okay, tell me guys. What are the two learnings? The first thing we have learned, L is equals to mu naught n square L A. This is our learning, and where A is equals to pi r square. And what is our second learning? V induced is equals to negative L di over dt. Clear? If current increase, voltage decline. First case, opposite directions. Okay. Second thing, if current reduce, voltage increase, but the directions are same. Is it fine? These are your learnings. Okay guys, now let's move to the question. Now question number 1. What is this question? And this is very important question, huh? So I will explain you this question in too much detail, so you need to focus, huh? So the question is exercise 9.47. The figure shows the current through 10 mH inductor. Okay, so inductor is given, L is 10 millihenry. Okay, as we know, Henry is the unit, so just solve it. 10 multiply 10 raised to power negative 3 Henry over a time interval. Okay, time is given 8 millisecond, which is equals to 8 multiply 10 raised to power negative 3 second. Okay, draw a graph showing the self inductance. Okay, we need to draw the graph. This is very important. Draw the graph showing the self-induced potential difference V L for the inductor over the same interval. Okay, the time period is the same. Okay, we need to understand this graph very minutely. Before that, a small part you need to understand. Let's say in terms of graph, we have the word called slope. So if we check the formula, V induced is equals to, what is the formula? Negative L di over dt. Yes or no? And the graph 1 which is given. So graph is between I versus t. I versus t. So from here, can I solve I versus t, which is equals to slope of the graph? Yes or no? So because so that I can find out the V induced. Okay, so now give them the name, different names. Let's say this is your line number 1. Okay, first give them the name A, B, C, D, E, F. Okay, so give them the name line 1, line 2, line 3, line 4, and line 5. Okay, solve them so that we can solve the you can say the induced potential difference in a smooth way. So okay, let's start with the line 1 and we will find the slope. Line 1. Okay, so how to solve the slope? So we know what we are looking for. We are looking for di over dt, which means I2 minus I1 over T2 minus T1. Okay, for case 1. So what is your I2? Okay, just check. So I2 is your 4 minus 0 divided by, what is your time here? Okay, just check. That is the 2 millisecond. So 2 minus 0 bracket, it's a millisecond, multiply 10 power negative 3. Clear? So can we solve this? So what we get, 4 divided by 2 and goes up, so multiply 10 power 3, which is equals to 2000. Yes or no? So this is your first di over dt. Can I say di1 over dt? That is for line 1. Similarly, we can solve for line 2, 3, 4 and 5. Okay, just step by step. Okay, line 2. I'll change the color. For line 2, di2 over dt. So can I say I3 minus I2 over T3 minus T2. Okay, as B to C, the line is straight. So can I say 4 minus 4 divided by time, which is equals to 0. Which is equals to 0. Okay. Similarly, I have to solve line number 3, 4 and 5. Guys, now you need to try yourself. Till then, I'm solving here. Okay. Line 3. For line 3, di3 over dt3, which is equals to I4 minus I3 over T4 minus T3. Okay, so just solve it for line 3. That is negative 4 minus 4 divided by, what is the time? 2, 4, 5, 6. So it should be 6 minus 4 multiply 10 raised to power negative 3. Solve this value. So what is your answer once you solve it? So it should be negative 4000. Okay. So first is your 2000, second is your 0, third is your negative 4000. Similarly, line number 4, di4 divided by dt4, which is equals to I5 minus I4 divided by T5 minus T4. Okay, place the value. So what should be the value? Yes, yes, yes. So it goes up. So 2 minus 4 divided by, and 2 minus, okay, it should be double minus. First understand, 2 minus, and what is the value? Negative 4 divided by, the time values are 7 minus 6 multiply 10 raised to power negative 3. Solve this. So what is the answer? 6000. Okay. Fifth point, so that I can use all these values. di5 divided by dt5. So I6 minus I5 divided by T6 minus T5. Solve this fast, fast, fast. Okay, so the maximum value is 2 minus 0 divided by, okay, what we have, 8 minus 7. 8 minus 7. No, it should be 0 minus 2, not 2 minus 0. Because the final minus initial. So 0 minus 2 multiply 10 raised to power negative 3. Okay, solve this. So what is the value? Negative 2000. Okay, we have all the 5 values. So what are the answers? Just write down them. First, di1 over dt equals, what is the answer? 2000. Then di2 over dt, then we have value 0. Third is di3 over dt, that is your negative 4000. di4 over dt, which is equals to your 6000, and di5 over dt, which is your negative 2000. Till here clear, guys? Okay, 3, 4, 5. Now we need to find the v so that we can solve the graph. Is it fine? Okay, so what is the value of v? Now just use these things and we need to find out. As we know, v induced is equals to negative L di over dt. Yes or no? This is the formula. Okay, use it. So v induced 1. So can I say negative L di 1 over dt? Yes or no? Okay, place the values. So V1 is equals to negative. Value of L is fixed. 10 multiplied 10 is to the power negative 3. Okay, what is the value of first? Okay, 2000. Solve this. What is your answer? Negative 20 volt. Similarly, solve V2. Negative 10 multiply 10 is to the power negative 3 multiply 0. So answer is 0 volt. V3 negative 10 multiply 10 is for negative 3. What is the value? Negative 4000. Okay, so answer should be positive. It should be positive 40 volt. Okay, V4 negative 10 multiply 10 is for negative 3 and the bracket 6000. So the answer is negative 60 volt. And similarly V5 negative 10 multiply 10 is to negative 3 multiply negative 2000, which is equals to your positive, what is the value? 20 volt. Clear guys? You understand? Okay, now we need to, okay, first I need to add a paper here, add a page. Okay, now just try to understand the graph. I need to draw a graph which has a different values. Okay, what is this? Remove this and draw a proper graph, positive as well as negative, and here also. Okay, here should be 10, 20, 30, 40, 50 and 60. Okay, these are the values and I will write voltage. Clear? Okay, that is the induced voltage. Okay, and this is your time. So 1 second, 2 second, 3, 4, 5, 6, 7, 8, because time is given and time is in your millisecond. Okay, so it should be negative 10, negative 20, negative 30, negative 40, negative 50 and negative 60, because we have the value still 60. Okay, now your case number 1. As per case number 1, what are the values? We have value till time is your 2 second, it is 4, then your 5, it is 6 and it is 8. Okay, now just solve them. For the first 2 seconds, what is the value? Let's see what is the value. For the first 2 seconds, we have a value of 20 volt. You can write 2 seconds. Yes, okay. So can I draw like this for 2 seconds? Like this one is your curve for the first 2 seconds. Okay. Then, okay. Then just check the values. This is for 2 to 4 seconds. Second graph. Okay, 0 volt. Okay, place it. 2 to 4. This is your second graph. Okay. Third graph. Now we need to check the third value. Third value is 40 volt. Third value is 40 volt. And third graph starts from this value 4 to 6. Okay. So 4 to 6. 4 and the value is, what is the value? 40. Okay, just go here and till 6. And this is your graph part. Is it fine till here? Okay, fourth, that is the negative 60. Just check. Fourth is negative 60. Okay, negative 60 is up to what second? You need to check this. This is very, very important, huh? So just check. We have the value from 6. This is the time. You can say time is equals to 6. And this time is equals to 7 seconds. So 6 to 7. 6 to 7. Okay, I have up to here. Okay, 60 and this one. So this is your 6 to 7. Okay. Now the last one, 7 to 8. 7 to 8 is plus 20. So plus 20. So it should be 728 plus 20. Now guys, you understand, and you can join this one also. So this is your solution, and you should understand how to solve this type of question. And there is a logical and mathematical proof so that you can understand in which time zone we solve the particular question. Okay guys, till here clear? Okay, now move to the next question. This question is already asked in the previous year, so you have to be very conscious that which type of question it is. Okay guys, now let's start with the last year exam question, and this is a question in front of you. A long solenoid has a circular cross section of radius. Radius is given 9 centimeter. Okay, let me segregate this part so that you can easily solve it. Radius is 9.0 centimeter. Okay, first of all, convert this. 9 multiply 10 power negative 2 meter, or you can write 0.09 meter. Okay, is it correct? Fine. Length L is given. L is 17.0 centimeter. Convert this. 17 multiply 10 raised to power negative 2 meter, or 0.17 meter. Okay, the number of turns in 1 meter, number of turns in 1 meter means small n, which is equals to capital N by L. Okay, this is a different case. Okay, for the solenoid is your value is 3.2 times 10 raised to power 3. Okay, and it's a number, there is no unit, and it carries a current. Okay, current is given I, which is equals to 0.5 ampere. Calculate the magnetic energy stored. Calculate the magnetic energy stored in the solenoid. So we need to find magnetic energy. Okay, there is a formula, half Li square. Half Li square. As per the, we have to use the self-inductance. So you should know this is the energy, and this is also covered in other videos that this is the energy of the self-inductance. So we should know, as per the formula, UB is equals to half Li square. Okay, I we already know. Okay, there is a value, but what is the value of N? I told you the formula, mu naught N square L A. This is the formula, yes or no? And what is the area? We know pi r square. So all values are given, place them. Okay, use the different color. So UB is equals to, okay, I'll write somewhere else. Okay, here I will solve. So UB, place the value half. Okay, L is your mu naught N square L times pi r square. Yes or no? I times square. So place all their values. Half, what is mu naught? 4 pi times 10 raised to power negative 7. Clear? N square, what is the value of N? N is this much. 3.2 multiply 10 raised to power 3 square. Okay, first of all, cut this value and put it here. Okay, come here. Clear? Okay, now what we need to do, N square L is your 0.17 multiply 0.17. okay, then pi r square, where is r? 0.09 square multiply current is 0.5 square. Okay, so guys, just put all these values in your calculator, and once you solve it, you will get 6.96 multiply 10 raised to power negative 3 joule. Guys, it is not like that they will use the self-inductance and they will tell you to find only L. They can ask you other things also. Just like in this question, they ask you the energy. So we should know this formula, and this formula is also given in your data booklet also. Okay, and for this question, I just give you the answer sheet also. and I just take it from the exam, so you can check. This is the this is for your formula for 2 marks. What you have done, ub is equals to half li square, and place the value of l. Place the value of l. This gives you 2 marks, and then you just need to place all the values. This will give you 2 marks, and final solution, this will give you the 1 marks. Like this, you will get the 5 marks. Okay guys, so the first question, or you can say the question number 16, is completed now, and start practicing. And this type of question, if you find somewhere else, you can ask me, but these are the questions which I find out and which is suitable as per the EOT. So guys, now we will meet in the next video with question number 2 on the basis of transformer. So till then, take care, bye, and keep on practicing.